Now we will find the minimum of the functional Iyx equal to integral from 0 to 1 by 2 y dash square plus y dash plus y dash plus y dx if the values at the end points are not given. That means end points are not fixed, end points are variable. We shall solve this problem. Solution is like this. The Euler-Lagrange equation gives us y dash plus 1 minus d by dx of y dash plus y plus 1 equal to 0. If you solve this, we will get y dash plus 1 minus y double dash minus y dash minus 1 minus 0 equal to 0. Derivative of 1 is 0. Y dash and minus y dash cancel. This implies that y double dash equal to 1. This is equation 1. If we integrate this equation 1, we will get y dash equal to x plus some constant c1 suppose. This is equation second. Further integrating, we get y equal to 1 by 2 x square plus c1x plus c2. Thus we get y, where c1 and c2 are constant of integration and to be determined the values of y at the end points are not prescribed or are not given. In this case, we shall use the variable endpoints case. Therefore, we shall use the condition dou f by dou y dash at x equal to 0 is 0 and dou f by dou y dash at x equal to 1 is also 0. Therefore, we can see that y dash plus y plus 1 at x equal to 0 is 0 and y dash plus y plus 1 at x equal to 1 is also 0. From equation 2 and 3, what is equation 2? Equation 2 was y dash equal to x plus c1. This was equation 2. And y equal to x square by 2 plus c1x plus c2. This is equation 3. From these two equations, we have y dash at 0 equal to c1 and y at 0 equal to c2. Similarly, y dash at 1 equal to c1 plus 1 and y at 1 equal to 1 by 2 plus C1 plus C2. Thus, the condition 5 becomes y dash plus y plus 1 at x equal to 0. That means y dash 0 plus y at 0 plus 1 equal to 0. This implies C1 plus C2 plus 1 equal to 0. This gives us C1 plus C2 equal to minus 1. Now, y dash at 0, second point, y dash plus y plus 1 at x, y dash at 1 plus y at 1 plus 1 equal to 0. This implies y dash at 1, that means C1 plus 1, plus y at 1, that means 1 by 2 plus C1 plus C2 plus 1 equal to 0. This becomes C1 and this C1, that is 2C1 plus C2 plus 5 by 2 equal to 0. And from this we get 2C1 plus C2 equal to minus 5 by 2. We shall solve these two equations for C1 and C2. Solving these two equations for C1 and C2, what we shall do? We shall subtract equation 1 from second, that is 2C1 plus C2 equal to minus 5 by 2 and C1 plus C2 equal to minus 1. We shall subtract this. Therefore, we will get 2C1 minus C1, that is C1, C2 minus C2 get cancelled, and minus 5 by 2 plus 1 equal to minus 3 by 2. And if I substitute this value in equation 1, that is C2 equal to minus 1 minus C1, that is equal to minus 1 minus 3 by 2 equal to minus 1 plus 3 by 2, that is equal to 1 by 2. Thus, C1 equal to minus 3 by 2 and C2 equal to 1 by 2. Therefore, the required curve becomes minimum is y equal to 1 by 2 x square minus 3x by 2 plus 1 by 2. That is nothing but 1 by 2 times x square minus 3x plus 1. This is the required curve. Y equal to 1 by 2 into x square minus 3x plus 1. Thank you.